Hi, and welcome back to Math with Sophia, a part of Sola Math. Find more math resources at solamath.com. In this video, we'll be covering domain and range and how to find the domain given a set of points, given a graph, and given an equation of a line. So let's get started. So first, let's go over what domain and range are. So the domain is the set of all possible x values or input values. And the range is the set of all possible y values or output values. So let's go over some examples. So in our first example here, we're given a set of points. So the domain, which I'm going to abbreviate with a D, is the set of all possible x values. So we're going to look at the x coordinates and just list them. And we're going to use curly brackets to indicate that we're listing them. 0, 5, 7, 1, and 8. So that is our domain. And then our range, like we said earlier, is the set of all possible y values or output values. So we'll look at our y values and list those. So we have -3, 4, 2, -3, 11. So we list -3, 4, 2, and we have -3, but we already listed it, so we don't need to list it again. 11 is our last one. So our domain and range of our first example are given right there. Now let's look at another example. Okay, so in our second example, we're given a list of points again. So we're going to write our D for domain and list our set of input values. So we have -2, 7, 3, and -5. -2, 7, 3, and -5. And you can list these in order, but you don't have to, from least to greatest. And our range is our y values. So we have 9, 1, 1 again, and 9 again. So we only have to list each number once. So curly bracket, 9, 1, and then we have 1 and 9 again. So we are going to close the bracket there. And that is our domain and range for example 2. Okay, let's move on to some more examples. So here we're given a graph, which means this is going to be slightly different. The way we list our domain and range is going to be slightly different when we're given a graph or an equation. And that's because this here is going to be a span of numbers or values rather than a list. So there's some important things that we need to know to write our domain and range given a span of values. The first thing is how we write them. So the way we write this is the lowest number or lowest value goes first, and then we write a comma, and the highest value is next. And then on the outside of this, we either write a parenthesis, and the parenthesis means the value is not included, or we write a bracket. And brackets indicate the value is included. So what does this mean? Well, let's start with domain. And remember, the domain is the set of x values. So we look at our line, and what is the lowest x value that our line contains? Well, let me look at -6, for example. -6 is not included in the line. -5, -4. The lowest number that is included in this line is -3. So we list our -3 first. And looking back here, it's a closed circle, which means the value is included. And when a value is included, we use a bracket. So we put a bracket next to the -3. Then our comma, and now we look for the highest value. So our line goes up to here and ends right there, which is at 6 on the x-axis. So our highest value is going to be 6. And this is an open circle, which means we're going to put a parentheses, because open circle means the value is not included. So that is our domain. Our set of x values is from -3 to +6. Now let's look at range. So we're going to look at the y values now. The lowest y value is at 2. So we put our 2 first, and it's a closed circle. So the 2 is included, which means another bracket. And then our highest value is up here, which is at y = 5. So comma 5, and it's an open circle, so it is not included, which means it's going to be a parenthesis. So our range goes from 2 to 5. And that is our answer to what the domain and range is for this graph. Let's look at another example. All right, here we're given another graph. And let's keep in mind what parentheses and brackets mean. So this is how we write it. Lowest number comes first, highest number comes second. A parenthesis means the value is excluded, and a bracket means the value is included. So let's go ahead and get started with our domain. Looking at our x values, our lowest is at 2. So first comes 2, and it's a closed circle again, so it's going to be a bracket. Comma. And now this graph is a little different than the one before because this is a ray, which means, as you can see from the arrow, it continues on. So this never stops, which means as it goes up, we can see it's going in the right direction. So these x values are all included, and they're going to continue forever, which means they go to infinity. And since infinity isn't actually a specific value, it can't be included. So whenever infinity is involved, we use parentheses. So our domain for this graph goes from 2 and continues on forever in the positive direction. Now let's look at the range. So the lowest y value is at -4, and it's included. So that'll be a bracket. So bracket and -4, comma, and as we said before, this continues on infinitely, and it's continuing in the positive direction. So continues to positive infinity. And that is our domain and range for this function. Let's look at the next example. Okay, so again, we have another graph. And let's keep in mind parentheses means the value is excluded and bracket means it's included. So starting with our domain, the lowest value our domain can be, well, this also continues on infinitely. As it goes up, it also goes slightly to the left, which means this continues on infinitely to the left. So there is no lowest value, which means the first part of our domain is going to be -infinity. And infinity always goes with a parenthesis. Comma. Now let's look at the right side here. Again, this continues on up and it's going slightly to the right, which means these x values are all included. And they're going to continue forever, which means our second value here is +infinity and a parenthesis. So our domain from -infinity to infinity means all of these numbers, all of the x values are included. That is often written as all real numbers. Or you might see it listed as this R, which represents all real numbers. So whenever you see -infinity to +infinity, that is the same thing as all real numbers. And that can be for the domain or the range. Let's move on to the range. So the lowest y value, the lowest this function goes is 0. And actually, this function you might recognize as a parabola. The equation for this function is y equals x squared. But back to the range, the lowest value is 0, and that is included. So that's going to be a bracket, because this function does actually hit 0. And then the highest value, well, this keeps on going up infinitely. So it's going to be comma infinity. And then we close it with a parenthesis. And that is our domain and range for this function. Let's move on to the next example. All right, here we're given another graph, and this one's slightly different because of this open circle. So starting with the domain, let's look at the lowest possible x value. Since this continues on forever in the negative direction, our first value is -infinity with a parenthesis. And then at first it looks like you might think we would go to +infinity. But we can't write +infinity because that would mean all numbers are included. So we can't immediately write that because there is this open circle here. So we have to stop at this open circle, which is at -5. So comma -5. Now this isn't the entire domain. This only includes all of these values to the left up to here, which means we're going to have to do 2 intervals. When we do that, we use a U to connect them, which means union, and then we write our second interval after it. So starting at -5, where we left off, that would be our lowest x value for this next interval. So -5 with the parentheses, because the -5 isn't included, comma, and this continues on in the positive x direction. So +infinity and parentheses. So as you can see, sometimes we have to list multiple intervals to get the full domain. And sometimes it might be more than 2. And anytime you add another interval, you just write a U to represent union. It means these are all included, however many intervals there are. Now let's move on to the range. So the lowest y value, it has happened to be on the left in our other examples, but the lowest y value here is, you can see this is going in the negative direction. So it doesn't matter left or right when we're talking about range. It matters up and down. So we're looking for the lowest y value right now. And as we can see, this continues on forever. So there is no lowest value. So negative infinity, with the parentheses, comma, and then as we go up, we hit this point right here, which is not included. So we have to stop at this point, which is at 4. So 4 is our next value with a parentheses since it's not included. And then we do our union so we can list our next interval. So we stopped right here. So 4 comes first in our next interval with the parentheses, comma, and this continues up in the positive y direction, so to positive infinity. And that is the domain and range of this function here. All right, our next example. So this example you might recognize as an exponential function. This is y equals 2 to the x. So starting with our domain, we can see this continues in the negative direction towards negative infinity. So we're first going to list negative infinity, comma, and then if we follow it to the right, again, it continues on forever in the positive direction. So it's going to be positive infinity with the parentheses. Again, this you might see listed as, or you could also write it as this symbol, this R with the double line, or written out as all real numbers. So you could write this, or you can write it as an interval. All right, moving on to range. So we're looking at the lowest possible y value. And as we can see from this, but more importantly, from our equation here, this continues on, and it looks like it could continue on down to negative infinity, but this will never hit 0. It just gets closer. It will never cross 0 or hit 0. It gets closer and closer to 0, but it'll never hit 0. So our lowest value is 0, but with a parentheses because it doesn't actually ever equal 0. And if we look at our equation, we know that for a fact because there's no number we can plug in for x that will make y equal 0. We could put in 0 for x, but 2 to the 0 equals 1. We could put in a negative number for x, but that would just give us a fraction for y. So this is never going to be, 2 to the x is never going to be 0 or below. So 0 is our lowest value, but it is not included. Comma, looking at our graph, it increases infinitely in the positive direction. So positive infinity is our next value. And that is the domain and range for this function. All right, here you might recognize this function as y equals 1 over x. It's a rational function. So starting with our domain, we can see this continues on in the negative direction infinitely. So it's going to be negative infinity, comma. And at first it looks like we could just go from negative infinity to positive infinity. But there is this break right here because we can't put x equals 0 into our equation because we can't divide by 0. That's not possible. So x will never equal 0, which means our first interval will go from negative infinity to 0, and 0 is excluded. But that isn't our whole domain because we have this other half over here. So we write our union, and then again, 0 is not included. But we have to write it because it gets as close as possible, infinitely close to 0, but it doesn't touch 0. So we have to write 0. We just write it as not included. And then this continues infinitely in the positive x direction, so to positive infinity. So that's our domain. And then our range, our lowest value, this continues in the negative direction. So our lowest value is negative infinity again, comma. And 0 is not included as a y value either because there is no number we can plug into this function to get y equals 0. So our function goes up to 0 but does not include 0. And then union, and again we start here at 0 and our function continues in the positive direction, so positive infinity. And that is our domain and range for this function. And now for our last examples. So example 9 is different because we're not looking at a list of points or a graph, but it's always helpful to either picture the graph, or if you want, you can always draw the graph to see it visually. To do it algebraically, first assume that we can plug in all numbers for x. We assume the domain is all real numbers, and then check and see if there's anything we can't plug in for x. So there is no value that we can't plug in that is not valid to plug in. We can plug in 0 for x, we can plug in any negative number, any positive number. So our domain for this equation, this function, is all real numbers. So negative infinity to positive infinity. And then our range, we can also get all real numbers. There's nothing excluded from the y values. So our range will include all real numbers as well. Now let's look at our final example. So looking at our equation here, the first thing to note is that it is a quadratic because of this x squared. So it's going to be a parabola, and since it's a positive x squared, it's going to be a parabola pointing in the positive direction. So again, the first thing we do when we write our domain is to assume all real numbers and then check. So we can in fact plug in any number into x. We can plug in negative numbers, we can plug in 0, we can plug in positive numbers. So this x will be all real numbers. And we can check by thinking about the graph of a parabola and whether it's a U-shape right on the x-axis or a U-shape somewhere else pointing upwards, it's still going to contain all of the x values. So our domain is all real numbers, or negative infinity to positive infinity. Now let's look at the range. So thinking about a parabola and looking at this equation, we can think of this as a parabola right on the x-axis pointing upwards, shifted down 3 units. 1, 2, 3. So our parabola is actually going to be down here on the y equals -3 line. So instead of 0 being our lowest y value, it's going to be -3. So -3, and it is included, so it's going to be a bracket. And again, that's because if we plug in 0, we'll get 0 squared. Without this 3, that would give us y equals 0, and 0 would be the lowest y value. But because we do have a -3, 0 squared minus 3 equals -3. So that is why our lowest y value in the range is -3. And it is included because we can plug in a specific value and get exactly -3. So then our next number in the interval, if we think about our parabola, it continues in the positive direction infinitely. So it'll be positive infinity. And if we think about this algebraically, there is no number that is too high to plug into x. So there is no highest number that we can get for y either. Since there's no highest value, infinity is our second part of the interval. And that is the domain and range of y equals x squared minus 3. And that is finding domain and range. And for more information on finding the domain and range of equations, because there are lots of different kinds of equations that can require different strategies, there will be a follow-up video to this one. Hopefully you found this video helpful, and if you enjoyed it, hit the like button and subscribe for more.